So here in this episode of Talk the Thought Process, we're going to talk through that process of working with mass and with moles. So we'll be doing unit conversions involving mass to moles and moles to mass. Now, a mole, by definition, is a quantity that contains 6.022 times 10 to the 23rd things, right? And so it's always important when doing problems involving moles is to make sure you're clear about what things you're talking about, right? Suppose we were talking about eggs, right? These are relatively big things compared to atoms and molecules and ions. So a mole of eggs will take up a lot of space and a lot of mass. Remember, a mole of eggs would just be 6.022 times 10 to the 23rd eggs. So we don't talk about moles of eggs because it's a quantity we would never deal with. But when we deal with atoms, molecules, and ions, these are really, really, really small things. And so moles of these are quantities that we can work with and the amounts that we work with in the lab. But we don't measure things in moles, right? In the lab, we'll measure things in mass units. We might measure volume, but for now, we're going to talk about mass units. We might measure in milligrams, grams, or kilograms, an amount of something. But as chemists, though, we think about things in terms of moles because it's all about the particles. Those particles, the atoms, the molecules, the ions, they're combining with each other as discrete particles in specific ratios. So we always want to be thinking about what's happening in terms of these particles. And we talk about those in terms of the moles. So because of this, we're always kind of marrying the real world where we're working with grams, kilograms and milligrams and so forth to that world within our brains where we are imagining the molecules, ions, and atoms that make up chemistry. Okay, so it's really quite simple. We've done other conversions before, converting feet to miles and different things like that. We can easily convert mass to moles and moles to mass as long as we know the conversion factors. And these are all provided in the periodic table. So this is the key thing to understand about chemistry, that the mass that is provided on the periodic table is the mass in grams of 1 mole of that atom. 1 mole of that atom, that means 6.022 times 10 to the 23rd atoms, will have the mass in grams that we read from the periodic table. So we always need to be referring to our periodic table when we're converting mass to moles or moles to mass. So here in this handy periodic table, we can look, for example, at iron, Fe, iron. And the mass that we have there is 55.845. So that means that 1 mole of iron atoms has that mass in grams. Okay, those are the conversion factors we'll use in these converting mass to moles. So let's start with some simple numbers here, right? If you have 10 moles of sodium, Na is for sodium, how many grams of sodium do you have? Okay, so in doing a kind of problem, we want to realize we're just doing a conversion, right? And we're going to start with what we're given in the problem, which in this case is 10 moles of sodium, Na. And we want to find out how many grams that is. So that means we want to convert this to get an answer that's going to be in grams of sodium. Okay, so we need a conversion factor that'll convert grams to moles. And what we use is the periodic table. So if we go back to our periodic table and we look at sodium, we see the mass there, 22.990 grams, meaning 1 mole of sodium is 22.990 grams. So we'll write that down here as our conversion factor. 1 mole of sodium equals 23.990 grams. Sorry, I think that's 22. I need to put my glasses on. 22.990, because I always remember that sodium is about 23 because I use it so often. So 22.990. That's our conversion factor. So we multiply by the conversion factor. We're going to put moles on the bottom because we want that to cancel out. And we'll put the grams on the top. 22.990 grams. And we'll get out our calculator and we'll do our math. But hopefully we don't even need to do that, right? We can multiply 10 by this number and we'll get 229.9 grams of sodium. Okay, so again, this errors that students make will always be flipping over the conversion factor, and there are two ways to check. One way is that your units will cancel, moles will cancel. You'll be left with the grams, which is what you want. And the other way is to sort of think it through. If 1 mole is 22.9 grams, and you have 10 moles, you have 10 times as much. So it's 229.9 grams. So always think through the answer and if it makes sense. All right, next problem. If you have 3.4 grams of sodium, how many moles of sodium do you have? And again, we have the same conversion factor. 1 mole of sodium equals 22.990 grams of sodium. Where did we get that? From the periodic table. Did we memorize that? No, we look it up in the periodic table. So again, to do the problem, we start with what we're given, 3.4 grams of sodium. And on the right here, we want the answer to be in what we want, which will be moles of sodium. We use our conversion factor. In this case, what do we put on the bottom? We put the grams on the bottom because we want the grams to cancel out with what's on the top. This is equal to 1 mole of sodium. So remember, the conversion factor has equal quantities on the top and the bottom. It's just the units are different. And 1 mole of sodium is equivalent to 22.990 grams of sodium, and we know that from the periodic table. So now we can do our math. We can get out our calculator. And we have 3.4 divided by 22.99. That's going to be 0.15. 0.15 moles of sodium. So again, ask yourself, does it make sense? And so sometimes, just to check yourself, you can just say, okay, if I have 3.4 grams of sodium, do I have less than 1 mole or do I have more than 1 mole? Well, if 1 mole is 23 grams, then you have 3.4, you have less than 1 mole. So your answer better be less than 1 mole, 0.15 moles. Okay, so it's quite simple, converting grams to moles and moles to grams. Just have to use your periodic table to get your conversion factor, and then also make sure that you have these set up correctly. All right, so here's a problem for us, again involving sodium. How many grams of sodium are in 0.46 moles of Na2O? This is sodium oxide, right? This is the chemical formula that exists, a ratio of 2 sodium atoms for every 1 oxygen atom in there. Okay, so what are our conversion factors? How many grams of sodium are in 0.46 moles of sodium oxide? So what do we know? Okay, we still know what we knew before, which is 1 mole of sodium equals 22.990 grams of sodium. And we're starting with 0.46 moles of sodium oxide. So we never need to figure out from there how much sodium we have. So what other conversion factors do we know here? Well, we know that for in 1 mole of Na2O, 1 mole of Na2O contains 2 moles of sodium and 1 mole of oxygen, right? So we know that again from the chemical formula, right? That's what these numbers mean. They convert in moles, not in grams. 2 moles of sodium for every 1 gram of oxygen. Right, so the question is, how many grams of sodium are in 0.46 moles of sodium oxide? So we'll start with what we're given, 0.46 moles sodium oxide, Na2O. And we want to know how many grams of sodium we have in that sample. Okay, so we have moles of Na2. So since we know how to convert moles of Na to grams of Na, we just did that in the last problem, we just have to figure out how many moles of Na are in these 0.46 moles of Na2O. Okay, so we can set up our conversion here that for every 1 mole of Na2O, we have 2 moles of sodium. How do we know? Because the formula is Na2O. Now we'll be able to cancel these out. We'll have moles of sodium, and we can convert that to grams using the conversion factor we've already used. 1 mole of sodium is 22.990 grams of sodium. We'll see that our moles of sodium will cancel out, and we're going to calculate that. So 0.46 times 2 times 22.99 equals 21.15 grams of sodium. Okay, so when we say talk the thought process, what we mean is talk it through, right? We're starting with what we're given, 0.46 moles of sodium oxide. We want to end up with what we want, grams of sodium. We know how to convert grams to moles, so we need to know first how many moles of sodium are in this 0.46 moles of sodium oxide. We know there's 2 moles of sodium for every 1 mole of Na2O. How do we know? We know because the formula here shows us that 2 moles of sodium, that's what the 2 means, for every 1 mole of Na2O, the whole thing here. Okay, and then for every mole of sodium, we can convert that to grams of sodium. We know that 1 mole of sodium has a mass of 22.990 grams. And so we multiply through and we get the answer that we want. So what's important in doing these problems, and as we talk through the thought process, what we need to do is make sure that we understand every step, right? This is what we're given. This is what we want. This we get from the chemical formula. This we get from the periodic table. All of the units cancel that we want to cancel, and we're left with the units that we want. And it's that simple. Okay, so we've performed some unit conversions involving mass and moles. You'll need to do this over and over and over again in chemistry, so it's important to make sure you understand this process. Talk it through in your head or out loud.